So we saw in section 12.3 and 12.2 that solving 3x3 systems equations with, with pen and paper is kind of a pain. So we're going to move towards solving it a little bit more electronically using our graphing calculators. And it's going to first start with matrices and learning some things about matrices. So your calculator doesn't necessarily need to understand that it's X, Y, and Z. It could be A, B, and C. What your calculator really cares about is what are the coefficients here and what are the numbers on the right-hand side. So if we're just going to give the calculator the bare minimum that it needs to know, then it needs to know a bunch of the numbers. And we're going to put those numbers in a matrix. So it's going to look like this. Let's just write down the coefficients here. 1,
1, 2.
2, good.
2, 1, -1, 5. 4, -5. 0.
0, nice. And then 4. And so that's kind of a numerical representation of your system of equations, keeping in mind, and it's not really written, but sometimes I'll do this, keeping in mind that the right-hand side is really the constants on the right-hand side for your system of equations. And now you've written this as a matrix. So that's kind of nice. It's the first step in being able to solve these things on a graphing calculator. Now, as far as this matrix is concerned, the size of this matrix, its dimensions, are 3 rows by 4 columns. So 3 by 4 matrix. It's always row then column. For like my college algebra class, when we go much more in depth with matrices, I actually bring in some RC Cola, and I joke about it being my corporate sponsor. Silas, you're shaking your hand. You don't like RC Cola?
No, I like RC Cola. That was not a good joke.
Oh, okay.
I'm sorry.
But it's actually been around for quite a long time. Royal Crown. And last I knew, you could actually get this stuff on a vending machine at the campus of Michigan State. But other than that, it's not exactly around a lot. Maybe even bought out by the Coca-Cola company. So RC Cola. So there you go. But the reason I joke about it is because you need to remember row then column in that order. When we talk about matrices, it's always in that order. If you create a matrix that's 4 by 3, it's not going to fit what we have here. All right, so this is an augmented matrix. And it corresponds to this system of equations pretty nicely. Let's try things in the other direction. Here's the augmented matrix. See if you can't write down the system of equations that goes with that augmented matrix. What does it represent? So Rachel, how about the top row? What is that telling me?
2x minus 2y
Good.
plus 4z is equal to 1.
Nice. And let's keep going with the second one. That'd be 3x plus y plus z equals 0. And last but not least, 2x minus 8y plus 3z equals -7. Nice. And that's it. Wait a minute, we got to give him some love.
That was easy.
Yes, well done. Now, if we manipulate our matrices in the right way, then we can make our augmented matrix look like this one right here. And I'm going to move over to a different sheet here just to give myself some room. So this is example C. I've got 1, 2, 5, 10, 0, 3, -7, -1, and 0, 0, 9, and 9. So let's look at what system of equations is represented by this augmented matrix, and then understand why it's nice to be able to work with something like this. So let's see here. Kelly, what's the top equation going to be, please?
X plus 2y plus 5z equals 10.
Awesome. Alan, how about the one below that?
3y minus 7c equals -1.
Good. And the last one is 9z equals 9. Now you've solved a lot of 3x3 systems of equations. Generally speaking, they're a lot of work, right? But does this one look a little easier somehow?
Yeah.
Yeah.
Can anyone tell me what z equals?
1.
Yeah. So that's kind of cool. If you look at the way we've got this matrix formed, you've got zeros in this little diagonal, this little lower triangular part of this matrix. And in doing that, that makes the system of equations pretty easy to solve. 9z equals 9, so z equals 1. Great. If z equals 1, let's plug that back into here and solve for y. So, okay, let's see what we got going for y. We get 3y minus 7 times 1 equals -1. So plugging in our z there. 3y minus 7 equals -1. 3y equals 6. So, hey, that's not too bad. What does y equal?
2.
2. Wow, I kind of like this one, right? It's working out pretty nice. Now that we know y and z, now what can we do?
Solve for x.
Yeah, I'm going to plug it back into, say, the top equation and solve for x. We have to plug it into the top equation because this is the only one that has an x in it. So we'll go in the top equation and see what we can get. So x plus 2y plus 5z equals 10. And that's x plus 2 times 2 plus 5 times 1 equals 10. So let's put those in here respectively, 2 and 1. On the left-hand side, I have x plus 4 plus 5. So it's really x plus 9 equals 10. So what does x equal?
1.
1. Wow. That was remarkably painless considering that we started out with a 3x3 system of equations. That was pretty nice. So how about we make a little gentleman's agreement? All your 3x3 system equations will look like that? Okay, fair? All right, we like that. All right, Kevin's gonna look at me a little suspicious, like, nah, I don't know. All right, yeah, I got a bridge in the Florida Everglades, I can tell you too, right? All right, so 1, 2, and 1. That's our solution, x, y, and z. Now, obviously, we're not going to always be given something like this. But the reason I go over an example like this is to show you that, boy, if you can get your system of equations in that form, boy, that's pretty nice. That's actually really nice when that can happen. So we're going to work towards that goal. And towards that end, we're going to be practicing with multiplying a row by something and adding it to another row, that kind of thing. So let's look back at our handout and start that practice. Down here with example D. So the first part of example D says, perform the following elementary row operations on the augmented matrix. Now this is just a 2x2 system of equations. 2 equations and 2 unknowns. And all they're asking you to do right here is switch the order of these 2 rows. So you're going to switch row 1 for row 2. Well, that's pretty easy. So that's going to be 4, -5, and 4, -2, 5, and -2. And that's it. That's all they're looking for you to do with that first part. It's one of a bunch of commands that you can use in working with systems of equations to try and eventually get it into the form that we had with example C. But let's try another one. This one says 3 times row 2 added to row 1. Now it's the row that you're adding to, that's the one that gets changed. So let me write that down here. Let's see, I'm not sure that one's gonna show up right enough. So the row you add to is the one that gets changed. So in this particular case, what we're going to be interested in is changing row 1 by adding 3 times row 2 to row 1. So it's going to look like this. 3 times 2 times -1 times 5 is going to be 6, -3, and 15. And we're going to add that to row 1. And row 1 was -6, 2, and -5. Okay, looking good. When we add these, we get a new row 2. So that new row 2 is going to have what as its elements?
0, -1.
0, -1, and 10. So this new matrix, keep in mind this is your new row 1. That new matrix is going to look like this. 0, -1, and 10. That's the one that changed. Here's the one that didn't. 2, -1, and 5. Okay. Are we okay with example D here? Now let's go back to our 3x3 matrices. These are representative of 3x4 matrices. That's going to be an augmented matrix for a 3x3 system of equations. Our goal is to make our matrices look like one of these two. This one is a little bit more work because instead of getting just any number on these diagonals, you want a 1 on these diagonals. This is more work. But if you get either of these, then solving these things is going to be pretty easy. So we're going to put these, our matrices, our augmented matrices in this form. Now you want to get zeros, these zeros here and here, you want to get these zeros into the matrix in a specific order. So you want to do this one first, this one second, and that one third. Once you get really familiar with this process, you could play with that, but until you're really good at it, I would stick with these. So we're going to do the work over here on our calculator that kind of emulates what we do here. These are augmented matrices. That corresponds to this system of equations. So let's learn how to put that into our calculator. Does anyone else need to borrow a graphing calculator from me? Everyone's got one? Okay. So you want to run program ROWOPS. I've installed it on everybody's calculator. So just press program and then enter. And it should give you some, oh, you know what? Man, we're gonna have to quit this already. But hopefully it's working. We gotta do one more thing before I start working on this. So let's quit the program. You should see a little cheerful message that reminds you of somebody handsome, athletic, and famous. All right, if you do, great. If you don't, that's okay. Now, we need to put in the matrix into our calculator. So what are the dimensions of this matrix? Silas, let me pick on you. 3 by 4, good. It's going to be a 3 by 4 matrix. So on the left-hand side of your calculator, fourth button down, right above the inverse key, what do you see?
Matrix.
And what do we have to do to get to the matrix menu?
Second matrix.
Yeah, second matrix. So second matrix, and now oddly enough, you want to go over to edit first. If there's no dimensions here, stuff like that, that's fine. You haven't used this before, that's great. Enter 3 by 4. Just type over whatever is there, if there is anything there. And let's enter in our matrix. 2, 3, and now when you press enter, it should move you from one entry to the next. So like when I press enter here, it moves you over to the next one. Make sure you put in negative numbers with the opposite key on the bottom row of your calculator. Don't put them in with subtraction. -1, -1, and -3. Finally, -4. I'm really regretting choosing an example with all these negatives here. It slows me down. -4. Ah, jeez. Last time. -4.
Third time is the sharp.
3, 1, and 10. All right. That looks good, I hope. Let's exit the matrix menu and then double check our work here. So to get out of this menu, you can hit the second key, then the mode key, that'll quit. But if you want to look back, if you're like, you know, I don't want to screw this up because I typed something in wrong, hit the second key and then hit the matrix key and press enter, and then enter again. It'll print out the matrix that you have stored for matrix A. It should match the one that we have in the example F. So are we good there? Is that matching? Okay. Now we can run program ROWOPS. So one more time. Everyone's with me on this? They've got that matrix entered into their calculator. Caleb, you okay? You got the matrix entered? You can, if you need to go back and enter something or change something, you hit the second key, then matrix, and then you go over to edit first, and then choose what matrix you're going to edit. And then you can change any of these numbers that you need to, etc. Once you're done there, you quit. You hit the second key, then the mode key to get out of there, and then hopefully you've got the right matrix now. All right, so let's run program ROWOPS. Let me clear out a couple things here. You can keep along with or follow along with the keystrokes. Program. If you get something like this, choose the first option. Now, what matrix did we have our system of equations in? A. So just type in a 1.
That's enter
Well, let's think about what we're going to do first. Our goal in working with this system of equations is to get our augmented matrix to look like one of these, most likely A. We just need zeros here, here, and here so that we can solve it as easily as we solved example C. So that's our goal. This is a process. If you wanted a fancy word for it, it's called Gaussian elimination. But let's see what we're going to do. Now, in getting it like this, typically speaking, I'm going to use this first term here to get zeros here and here. So it's handy if this is a 1 or a -1. And with that in mind, the first thing I'm going to do is I'm going to swap row 1 for row 2. So that's what we're going to do here. All these commands, whether or not you've got your TI-84 programmed with this or not, all these commands, all the matrices we're going to use are right here. So you can kind of follow along even if you don't have your graphing calculator. All right, so Alan was anxious to press enter. Let's press enter to continue. And the first option you should see here at this menu is a row swap. It says, okay, you want to swap a couple rows? Let's do it. So choose option 1. What rows do I want to swap? Well, yeah, 1 and 2. I want to get this 1 up into the upper left-hand corner. So I'm going to swap row 1, enter with row 2. enter. And there you go. Now you've got a 1 in the upper right-hand corner of this matrix. So let me pause here, make sure we're all still good here. Marcus? Elizabeth?
Sorry, yeah.
Okay. Carly? All right. Brady? All right. Mateo? All right. So press enter to continue. Now let's look at what we want to do next. Remember, I want to get zeros here, 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 and here, and I want to get them in this order. So the first thing I want to do is I want to get a 0 right underneath this number 1 here. Fancy word for that is called a pivot. How could I multiply something by row 1 and add it to row 2 to get rid of that and make it a 0? What would it be?
Keep that first one by
First one by
2.
negative 2. There you go. So if you do negative 2 times row 1 added to row 2, that should put a 0 right here. Now the reason I go through the pain of teaching you this program and writing the program is because it's very easy to make an arithmetic mistake, even if you know what you're doing. And using this program, we're not going to make an arithmetic mistake. Let's go to the fourth option. It's multiply, row, add. That's the one we want. So press the number 4. Multiply, row what? What row are we going to multiply by? Or what row are we going to multiply? 1. What are we going to multiply it by?
-2.
Negative 2. Well done. And we're going to add that to row 2. Bam. Look at that. It's doing the arithmetic for you. So cool. Let's keep going. I've got my 0 here. Looking at this, it says, oh, I want to get a 0 below that one next. So how am I going to make this third row, this number in the third row, a 0? What do I have to do now?
Times row 1 by 4.
Well done. 4 times row 1 added to row 4. All right, let's do it. So we're going to be using the same command or type of command again. If you press,
Row 3.
oh yeah, it should be row 3. Thank you, I said 4. There we go, row 3. If you did row 4, you'd probably get an error and the program would quit. Exit it, just exit it. Don't try and edit it at all. If you try and edit it, chances are you'll screw up the program. So let's press enter and choose option 4 again. So option 4, multiply row 1 by 4 and add it to row 3. Bam. Looking pretty good. Looking real good. So that brings us down here. I need to get one more 0 into this matrix. Now looking back, it was really convenient that I had a 1 up here because it made it easy to get rid of these two terms down here. I multiply the first one by -2, second one by 4. Now I'm no longer going to use the first row. I'm going to move down and start using the second row. But boy, I really miss having a 1 in that little pivot spot. So what I can do is I can swap these two. Because notice I've got a -1 right there. So let's do a row swap. Row 2 for row 3. That's going to put a -1 here and make my life a little bit easier as I get rid of that last number in row 3. I want to make that one a 0. So let's go back and do a row swap. So enter, row swap. That's the first option. This time I'm swapping what 2 rows?
3 and 2.
Yep. So row swap with 2 and with 3. And that's looking a little bit better. I need to get this last 0 here. How can I get a 0 where that 5 is?
Multiply the second row by 5.
Yeah, multiply the second row by 5 and add it to the third row. Notice I don't want to use the first row at all, because if I use the first row, if I multiply the first row by 5 and add it to the second row, I lose the 0 that I had here. So that's why we're doing this thing in the specific order that we are. Choose the fourth option, multiply row 2 by 5 and add it to row 3. So looking good there. 5 times row 2 added to row 3. And that gives us this system of equations down here. Let's see if we can't solve this one. This is where I wanted to get to. This is the point where we had zeros here, here, and here. And that's the magical form that we had in example C. In fact, kind of like example C, what does Z equal? Anyone just look at that?
1.
Yeah, Z is going to equal 1. So this is going to work out pretty nice. So let me finish this up over here. That's going to be x minus y minus z equals -3. Minus y minus 3z equals -2. And minus 14z equals -14. That last one is golden. That one really makes this whole process worthwhile. That tells me right away that z equals 1. Great. If z equals 1, let me put that back up into this equation and see what happens there. Let's see, I'll end up with -y minus 3 times 1 equals -2. So -y minus 3 equals -2. If I add 3 to both sides, 3 and -3 will cancel. Over here, I'll get +1. So if -y equals 1, what does y equal?
-1.
-1, thank you. 2 down, 1 to go.
Set paper up a little bit.
Yeah. Yeah. Last but not least, let's figure out what x is. So I'm going to plug that in here. X minus y minus z equals -3. And that's going to be x minus -1 minus z, which was 1, equals -3. The double negative cancel, so I get x plus 1 minus 1 equals -3, or x equals -3. Sweet. So it's a little bit more work to initially put this into your calculator, etc. But what I really like about it is that, you know, you can do all the work and not worry about arithmetic mistakes so much. So should be a little bit more user-friendly for you, should you choose to do it. Let me pause for a second. Is there anything about this you want me to recap, or maybe I went over a little too fast, etc.?
think I have it.
Think you got it? All right. Let's try it with a totally new example then. Now, on the exam, if you were to do one like this, you don't have to write all the matrices for me all the way down. What I'll accept is you just write the commands that you do. Row 1, swap with row 2, -2 times row 1 plus row 2, etc. So that's fine until you get down to here, and then maybe you just show me the work that I showed in solving it. So let's look at example G. Example G. X plus Y plus Z equals 11. X plus Y, or X plus 2Y plus Z equals 14. X plus Y plus 2Z equals 12. Great. First things first, let's write this as an augmented matrix. So in terms of an augmented matrix, let's see, Gavin, what number should I write here, please?
1, 1, 1, 11.
Mm-hmm.
1, 2, 1, 14.
Mm-hmm.
1, 1, 2, 12.
Perfect. Thank you, sir. Now, we'll keep in mind that this is the right-hand side. You don't have to write this little line here. Sometimes I do, sometimes I don't. But this is what we're going to put into our calculator. And we're going to eventually want to get zeros in the same spots we did with our last matrix. Get this one, then this one, then this one, in that order. Until you're really comfortable with this method, just stick with the order. So I guess one thing I have to do is I have to quit back to the main program. I'll hit 7, hit 7 again. On your calculators, you should be getting a nice message. I hope. All right. Let's see here. Let's go to matrix. So second, and then X inverse. All right. Then you want to go to edit. And it's something that's quirky about TI. You have to go to edit first and not to the matrix you want. So go to the edit menu, press enter. It's a 3x4 matrix still, so that's good. And this one doesn't have as many negatives, so I'm pretty happy about that. 1, 1, 1, 11, 1, 2, 1, 14.
111.
Oh, thank you. Yeah, 11. And then finally, 1, 1, 2, and 12. When you're done, how do you get out of this menu?
Second quit.
Second quit. Good. So let's see here. It's not a bad idea to look at your matrix. If you hit the second key, then the matrix key, and press enter twice, it'll print out your matrix. Make sure you, for instance, don't have 111 in the upper right-hand corner. So looking good there. So now we can run program ROWOPS. Caleb, are you able to get this matrix in? You got the expert help there? Thank you, Silas. So let's run program ROWOPS. If you get this menu here, then just press enter, and then you should see program ROWOPS again. Let's choose that one. And we're going to work with matrix A. So, I mean, I guess we don't necessarily need to type out matrix A when we do this initially, because it previews it for you here. But if you made a mistake, then here you'd have to exit the program, whereas doing it ahead of time means you don't have to exit the program. We've already got a 1 in this upper left-hand corner, so we don't need to do a row swap. Let's take a look at the commands we do need to do. I want to get zeros here, here, and then here. What's the first order of business? How do I get that first 0?
Multiply 1 by -1.
Yeah. -1 times row 1 added to row 2. So let's just keep a little list of those things. -1 times row 1 added to row 2. All right, let's do that here. So that's option 4, multiply row 1 by -1 and add to row 2. Great, that gives me a 0 just where I want it. I need another 0. Joey, where's the next 0 that I'm gonna get in this matrix gonna be?
Bottom left, where that 1 is.
Perfect. Bottom left, down here where the 1 is. What are we gonna do to get that to be a 0? Brianna? How can I get a 0 in the bottom left one like Joey suggested?
Multiply row 1 by -1 and add it to row 3.
Perfect. So multiply row 1 by -1 and add it to row 3. So let's just keep track of these again. -1 times row 1, this time add it to row 3. And let's see what that does for us. So that's fourth option down again. Multiply row 1 by -1 and add to row 3. So, wow. I think we're in good shape, right? I think we're in real good shape. In fact, we're in better shape than I would have imagined. So let's see, we've got 1, 1, 1, 11, 0, 1, 0, 3, 0, 0, 1, and 1. Wow, that's pretty nice. I outdid myself on this one. I'm so proud. All right. What can you tell me here? Isaac, what can you see just by looking at this? What do you see from this system of equations represented by that augmented matrix?
If the bottom 3 are the ones that are all zeros, so that would be z is equal to 1.
Perfect. So that's z equal 1. Great. Can you tell me anything more? Move up a row maybe.
Y equals 3.
There we go. This one says y equals 3. Great. Man. I'll have to put this one aside for special consideration later. Finally, we got this last equation, x plus y plus z equals 11. And, well, let's see. That's going to be x plus 3 plus 1 equals 11. Or x plus 4 equals 11. What does x equal? 7. Wow. Wait a minute. Do I have permission? Can we give this some love?
Sure.
Yeah.
That was easy.
Nice. Well done. Well done on that one. Really cool. All right. So, you know, this is a nice way to work with your system of equations to, you know, make your life a little bit easier. I gave you this program. You're free to use it on exams. I'd probably like something kind of like what we did here. Show me the commands and then show me your work at the end. That's what I'm looking for. There's another way we can solve these systems of equations. And it's fortunate for you that we already spent some time working with matrices. So that's going to make our life a little bit easier on this next part. Let's see, 6. Now, I want you to think back to solving just linear equations. In fact, a really simple linear equation. You don't have to copy this down right now. In fact, don't. Just watch for a moment. You've already solved this in your mind. X equals 3. But what I want you to keep in mind is that this, you know, what you're actually doing to solve this. You've got to get rid of that 7. Now, a lot of you probably said, all right, we'll divide by 7, and that's fine. Nothing wrong with that. But let me let you think of it a different way. What if I multiplied by the reciprocal of 7, the inverse of 7, on both sides? Now, 7 inverse times 7, or 1 over 7 times 7, that's going to cancel, right? And on the right-hand side, I get 1 over 7 times 21, which is 3. So basically, my solution is just doing that work over here. What we're going to do next is write our system of equations using matrices. So we're going to write our system of equations not as an augmented matrix, not like this, but instead we're going to write it, so let me look back at example G now and write it with matrices. So let's do, let's write out example G with matrices. I'm going to write example G as a product of a couple matrices. The first one is just going to be the coefficients, and this is going to be a 3 by 3 matrix. So those coefficients are exactly what we put here on the left-hand side. It's going to be 1, 1, 1, 1, 2, 1, 1, 1, 2. So I'll call that matrix A. And then I'm going to have another matrix, which I'll call X. And I'll write it like a capital Roman numeral 10, just to keep this distinguished from the variables X, Y, and Z. This is a matrix. Silas, what are the dimensions of this matrix?
3, 1.
Good, 3 by 1 equals, and then another matrix, B, which is going to be 11, 14, and 12. Okay. Easy peasy. Why am I going through this? I'm going to give you another cool push button way to solve your system of equations. So that cool push button way is going to be this. And you don't have to copy this part down if you don't want to. But here's our system of equations. AX equal B. Kind of like what we had here. Something times our variable equals something else. And what did I do? I multiplied both sides by the inverse. Well, you can find an inverse of a matrix. It's really a problem that we tackle more in college algebra. Although even there, I don't really go through it as much as I used to because technology is everywhere. But what I'm going to do is multiply by the inverse of this matrix. Now, the inverse of this matrix is not the same as taking the reciprocal of everything here. That's generally not the case. But when you multiply a matrix by its inverse, those are going to cancel out. You're going to get the matrix equivalent of the number 1, and 1 times anything is just itself. So to calculate your answer here, you need A inverse times B. That's all you're going to need. So let's look at it for this system of equations. We're going to have to plug in 2 matrices, A and B, and let's see how this works. So let's exit out of this. So quit out of this, and let's put in our 2 matrices. The first matrix is matrix A. That's going to be a 3 by 3 matrix. So go to the matrix menu, go to edit, and then press the number 1, or press enter. This time matrix 3 is going to be a 3 by 3. And very kindly, it looks like they just chopped off that 4th column, right? Does this look like the matrix A that we want? Mm-hmm. Yeah, looking good there. So let's exit out of this. And now we're going to edit matrix B. Second matrix. This time you got to go over to edit first and then down to B. You've got to do it in that order. I find it so annoying, but whatever. I've complained about that already. I'll shut up. Silas told us that matrix B is a 3 by 1 matrix. So let's put in those entries, 11, 14, and 12. Okay, that looks cool. If you want to look at your matrices, that's not a bad idea. Second matrix, there's matrix A, second matrix, here's matrix B. Both of those are looking like they're supposed to. So I'm free to solve. Now what you want to do to solve is you want to calculate precisely this stuff here, A inverse times B. Now, I'll tell you very bluntly that there's not too many Math 1150 instructors that are going to teach you this trick here, but it's a pretty cool one, and I want you to know it. So if I want to calculate A inverse B, my calculator can help me with that. I first need to type matrix A. So hit the second key, then matrix, and then a 1. Don't hit enter. Instead, we want the inverse. So hit the inverse key right there, and then we got to type matrix B. Now, if you feel inclined to hit the multiplication key, that's fine, you don't need to. Let's type matrix B next. So you should have exactly this here. And let's take a look at the magic that happens when we press the enter key. Bam.
No.
Ooh, ah, wow. Yeah, that's pretty cool. That's really cool. That you're well, there's a lot of work that's hidden in this calculation right here, finding the inverse matrix. It's much different than you might think, but once you've got that, then it's great. Now, there's a nice tie-in with this and stuff we're going to do in the next section, because not every matrix is going to have an inverse. And so that's a problem. Just like what we saw earlier with the solutions to some of the problems that you worked on today, you had one which was dependent and one which was inconsistent. Those problems wouldn't have an inverse matrix. So using this goes along with an understanding we're going to get in section 12.5. But let's try this again for a smaller problem, example H here. All right. Questions or comments on this one before we head to example H? All right. So example H looks like this. And look, this is so small that, you know, if you gave this to me, I wouldn't bother solving this with an inverse matrix. But it's good practice, and it's just a nice example of how this method works, so let's run through it. I need 3 things here. First of all, I need matrix A. That's going to be the matrix of coefficients. What are the coefficients in this problem? Just the coefficients, not the right-hand side, the coefficients.
2, 1, 1, 2.
2, 1, 1, 2. Great. So that's my A. Here's my X. X is just the column of variables, X and Y. Christian, help me out now. Someone else. What goes on with example or with B? What should I put here?
10, -4.
-4.
10 and -4. Great. Now, just like the last example, I want to calculate A inverse times B. But I need to put these matrices in first. Kelly, what are the dimensions of this matrix?
2, 2.
2 by 2, and what about this one?
1, 2.
Try again. 2 by 1. It's always row and then column. So that has much more importance when we start multiplying these kinds of things. So we need to enter those values into our matrices, hit the second key, then the matrix key. You need to go over to edit first. Let's edit matrix A. That's now going to be a 2 by 2, and it was 2, 1, 1, and 2. So that's our matrix A. We next need to edit matrix B, so I'm just going to hit second matrix, go over to edit, and edit matrix B. That's going to be a 2 by 1, and I'll put in 10 and -4. When you're done editing those, you can exit. You can look at your matrices. Second matrix, there's matrix A, second matrix B. They're looking good. What do I have to do to get my solution?
Matrix A, inverse.
Yeah, A inverse B. All right, so some of you guys are probably already there at the solution. Second matrix, A inverse, second matrix, B. Bam. 8, -6. That's your X and Y. Pretty sweet. One thing to look out for on the exam is, or not, you're not gonna get an exam on this, you're gonna get a quiz on this. There's two different ways I could ask you to work with a system of equations. I could ask for an augmented matrix, that's up here, augmented matrix, or I could ask you to write it as a matrix system of equations. Please don't confuse them. I get this quite often when I'm looking for this. This is your matrix system of equations. Matrix system. There's a lot more work that's done with these kinds of things. The nice thing about what we're doing is we're transitioning away from pen and paper to calculators and computers so that you can do bigger and bigger systems of equations. 3 by 3, 2 by 2, those are minuscule. In industry, a lot of times these system equations are millions by millions, which even storing that much data becomes a problem because you've got like 1 trillion pieces of data just to store the system of equations, and then you have to solve it. So obviously they're gonna do something a little bit more sophisticated than what we can do here. Comments or thoughts on either of these couple examples?
For the 3 examples we did earlier, for 2 and 3, if we tried doing like the system of equations, would it error out?
Yes.
Okay.
So the problems that we did earlier, the ones, you know, that had no solution. So if you tried to find an inverse matrix for this one, this system equation, if you wrote it as a matrix system equations, this would give you an error when you try to find A inverse. It would say singular matrix, no inverse, all right? And we'll learn what a singular matrix is in section 12.5. Anything else? Have a great one and see you.